Hi, my name is Lindsay Standage, and I'm a candidate for the Jury Education Master's Program in Curriculum and Instruction. Today I will be telling you about my thesis, the case study, my findings, and what it concludes. My project is titled Engagement and Retention of Information Through STEM-Based Teaching versus Traditional Teaching. In this study, I will look at how does STEM learning affect students and how does it compare to the traditional classroom environment. Thank you. My problem statement, or the reason and the motivation behind this study, is that there is a limited amount of STEM education within the lower elementary curriculum. And in correlation, there's a lack of teacher efficacy of knowing how to teach STEM education. So STEM is science, technology, engineering, and mathematics education, but specifically it focuses on more student involvement in their learning, more hands-on learning, students taking a more active participant position within the learning as they explore. It's more exploratory learning than anything. And this poses a problem, and this is my problem statement because there's been a recent push for STEM education within the past decade. And this is backed up by many campaigns, programs that associations have gotten behind, but yet it has not reached the lower elementary classroom. And that there's increased research as well in support of early indoctrination of STEM. So I wanted to take this study to look at why this is important, what do we find from it. So my rationale for the study, or my goal for this study, because there is this increased push for STEM education, but it's not made its way to lower elementary classrooms, I wanted to provide support of why STEM is useful to educators if they're contemplating the usefulness of it, specifically in lower elementary classrooms. And by lower elementary classrooms, I mean kindergarten through second grade. I'm also hoping that this will provide insight into lesson building and STEM implementation within the classrooms, because I want to make sure that I focus on teachers' efficacy and their feelings and sentiments about STEM education, and hopefully give them some sort of rubric for how they can integrate STEM into their lower elementary classrooms. STEM is very important, can be very beneficial as it is hands-on, explorative, and a very active type of learning. So I want to be able to provide research and more background information of how this can be useful at the lower elementary school level. So my 5 main points identified in my literature review. So pretty much I just gathered as much research and looked into as many studies as I could that talked about STEM, how lower elementary students learn, what does engagement look like? How do we get students to learn deeply? And what does STEM look like? So my 5 main points are outlined here. Number 1 is that the STEM push for STEM has been increasing within the last decade, but STEM education is not highly included in early elementary classrooms. And I put this as the number 1 because this is a main part of my goal and my rationale for my study. Number 2, when students are engaged within a lesson or activity, they're actually becoming active participants within the classroom and within the learning. And I think that is a very important thing to remember. Number 3 continues this thought as it says, like, active learning takes place when the students are either physically or mentally engaged within the subject. So this is now telling us that for students to be engaged and active, they have to be physically or mentally engaged within the lesson. So then the teacher takes on the role of a facilitator rather than a director during learning using Vygotsky's method of scaffolding. So a lot of the research that I saw said that when the teacher facilitates and gives ways for students to find the lesson objectives and to discover it on their own using support, this is how we get them involved in their learning, physically and mentally. Number four, the constructivist theory claims that when students are provided authentic and dynamic learning experiences, they are more deeply engaged and can understand the topic at another level. So this is working on their building skills of their schema and getting into those higher order thinking skills. And young students are creative, explorative, and love to ask questions about the world around them. And this makes STEM education a natural fit. And that was the number one thing that I saw about STEM in younger students, is that they're already creative and explorative as if. So might as well give them the type of curriculum or the type of lesson structure that best fits to their learning needs. With all of that to say, that brings me to my research question, which was the guiding force for my case study. And it says, what is the impact on student engagement and retention of information from STEM-based lessons versus traditionally taught lessons in kindergarten through second grade classrooms? And we will explore that on the next slide. So how I set up my lesson is that, or how I set up my thesis is how I wanted to do a mixed method study. So I wanted to gather qualitative and quantitative data. And I did this by implementing a case study within a Springfield school. I delivered lessons for kindergarten, first grade, and second grade to the teachers. I gave them professional development to help them learn how to present the lessons. The teachers then presented the lessons to their own students. And then the students took post case study assessments, and then I met with the teachers afterward. And so some of the ways that I collected all the data, and my qualitative and my quantitative, my number one was case study assessments. So I did a pre-assessment and a post-assessment. So the pre-assessment was done at the beginning before the case study lessons happened, so that I could separate and split each class into who would receive the STEM lesson and who would receive the traditional lesson. And I did a pre-assessment to make sure that each group had prior knowledge. And then the teachers would present the lesson. Then the students would take post-lesson assessments. This is so I could get my quantitative numbers. Then I had observations. I observed every lesson and took notes of engagement. And I had 5 different types of engagement that I was looking for. And then lastly, teacher interviews. I debriefed with the teachers a couple days after the case study lessons to get their thoughts and how they felt like it went. So what I found from the case study assessments is that each class scored above 80% on the pre-assessment, so they were already going in with a lot of prior knowledge, and obviously this is going to affect the results. But in that second bubble, it says that every class improved from the pre-assessment score to the post-assessment. So there was a improvement, a change in score all around. And the last bubble is that students showed no difference in lesson retention or the information that they gathered from the STEM lesson group to the traditional lesson group through the post-assessment. So there was no significance there. They scored around the same. Score. So my findings from the lesson observations from myself, and these are the 5 different patterns of engagement that I'm looking for: use of manipulatives, physical actions, visual sensory experiences, reiterations of thought, and oral expressions of feeling. In all 6 of the lessons, more patterns of engagement consistently occurred through STEM lessons from K to second. So the graph shows the total amount. And I was the one recording the patterns of engagement, so there is some biases there, but we'll see on the next slide that the teachers also agree with this sentiment. So when I debriefed with the teachers, I wanted to get their thoughts, and all teachers said that they would feel comfortable teaching STEM lessons with provided materials and instructions, but only one teacher said that they would feel comfortable without. And they said that they would When asked if they were more likely to use STEM lessons than traditionally taught lessons, only one teacher said that they would use STEM lessons. So I think this goes back to, yes, teachers have a lack of efficacy in STEM, but all three teachers believe that students were more engaged in the STEM lessons. All 100% of the three teachers said this, which I think is significant. In conclusion, STEM lessons resulted in more patterns of engagement than traditional lessons, and this was also backed up by the qualitative data of the teachers agreeing with this, that they also thought their students were more engaged in STEM. And they are more likely to be engaged in STEM lessons. It also concludes that STEM lessons and traditional lessons, in this specific case, there was no significance in their scores, but they are both adequate ways for students to comprehend and retain lesson information, as we can tell from their post-assessments improving from their pre-assessments. In conclusion, I think that there's three different ways that I would recommend for future research within this specific concept is one, lengthen the duration of the study. I feel as if this is done over a semester or a year amount of time, that you're going to see larger gaps in engagement and lesson retention between the two STEM lessons and traditional lessons. And number two, I only operated within the science part of STEM, so I would love to see the different topics of technology, engineering, and mathematics also being used within a case study. And then lastly, I would change the assessments dependent on the grade, even if it's only kindergarten through second grade, because I found that kindergarten through second grade is a very large gap to give all the same assessment. Now, they all did well on it, but I feel like if it is differentiated to the appropriate grade, then you can get more different and accurate results. Thank you for watching. And in conclusion, STEM can result in higher levels of engagement in lower elementary classrooms, which begs for the indoctrination within the curriculum. But more research needs to go further to understand lesson retention in comparison to different types of lesson structures, such as traditional teaching. Thank you.